In this video, we shall discuss about the new topic division algorithm for polynomials. Students, in the first chapter, we have already studied division of integers. When an integer is divided by another integer, then we get some positive integers as quotient and remainder, and which satisfy the property dividend equal to divisor into quotient plus remainder, and this property is also known as Euclid's division algorithm. Now in class 8 we have already studied about the division of polynomials, but here in this section we shall show that division of polynomials is also satisfy the similar rule which is known as division algorithm for polynomials. So this algorithm is very similar to Euclid's division algorithm that we have studied in chapter 1, and this algorithm says that if px and gx are any two polynomials with gx is not equal to 0, then we can find polynomials qx and rx such that px equal to gx into qx plus rx. The same rule here, just like for the division of two positive numbers, that is dividend equal to divisor into quotient plus remainder, and the remaining condition is same as where remainder Rx, this is the remainder, is also polynomial. Rx equal to 0 or degree of Rx is less than degree of Gx, that is degree of divisor. So this result is known as the division algorithm for polynomial. Now with the help of this algorithm, now let us solve some question of exercise 2.3. Here the question number 1, divide the polynomial px by another polynomial gx and find the quotient and remainder in which of the following. There are three parts, and simply there is nothing to be new. We have already aware with how a polynomial is divided by another polynomial. So let us take only one part of this question. Let's consider the second part. Let px equal to x power 4 minus 3x square plus 4x plus 5. Here the one term missing, that is the term containing x cube. So we can write it as x power 4 plus 0x cube. Here we can write 0x cube minus 3x square plus 4x plus 5, because x cube, there is no term which contains x cube. So it can be written as 0 into x cube, that is 0. Now gx is given x square plus 1 minus x, which is also not in standard form. So first of all make it in standard form. So that is x square minus x plus 1. And now divide this px by the gx. Here if we divide x4 minus x plus 1, so we see that the first time division goes x square times, then x4 eliminates here. So now we have this step in previous classes we have done. So here the quotient becomes x square plus x minus 3 and remainder is 8. You can see here and you can understand the steps. So therefore the quotient is x square plus x minus 3. The quotient is x square plus x minus 3 and remainder is 8. So with the same way you can solve remaining part first and third of the question number 1. Now similarly question number 2, the same question is here. Check whether the first polynomial is a factor of the second polynomial by applying division algorithm. Here we have to show that the first polynomial, that is t square minus 3, is a factor of the second polynomial, and this is the factor of this only when remainder equal to 0. We know that by the factor theorem, if any polynomial is a factor of another polynomial, if remainder must be 0. So we have we have to again, like question number 1, we let us divide this polynomial by t square minus 3, and by the same way the quotient is 2t square plus 3t plus 4 and the remainder is 0. Here since remainder is 0, clearly here remainder is 0, so this shows that t square minus 3 is a factor of the polynomial this. So in question number 2 we have to show the first polynomial is a factor of the second polynomial. Now in the next video we shall discuss. Now in the next question 3 and 4, they are very important question.